What we're going to do here is find missing angles. In these problems here, we're given a couple of side lengths, but we don't have the angle measure, so we need to figure it out. There's some formulas here. I might on this first one not use a formula. You're welcome to do that, when you do the problems on your own. But I'm going to just first show why is this true here, and what is this little -1 thing, okay? So let's just set this up as usual. So thinking about, we have this angle involved, and we have the opposite leg, and then we also have the adjacent leg that are given. So which of the ratios involves opposite and adjacent? Well, that would be tangent. Okay, that's, as if you remember from SOHCAHTOA here, that tangent is opposite over adjacent. All right. So now let's just plug in what we know. So we have 16 is the opposite, and then 8.6 is the adjacent. Now, how do you get theta by itself here? It's sort of stuck in the tangent here. You can think of the tangent as being a function, so it's sort of stuck in the tangent function here. Well, just like you undo any operation in math, you use the inverse. So you apply what is called inverse tangent to both sides. Okay, and so what that does, it basically undoes the tangent, and you're left with theta. And then over here, let me just write it out. We have this. Now you'll notice this now matches, well, the sides are reversed, but this matches the formula up here. So you're welcome to just sort of like skip to that step, using one of these formulas. But I just wanted to show, where that comes from. Now, how the heck do you find this inverse tangent of something? Well, luckily your calculator has it built in. Basically, this is going to come out to some kind of ratio, and what we're asking for is like what angle measure has this ratio. There's only one angle measure that has that tangent ratio. Okay, so we're going to go into our calculator now, and there should be on your sine, cosine, and tangent buttons. It's a little hard to see, but you have the little, sine to the -1, cosine to the -1. Now, that's not how you say it, by the way. How you say sine to the -1, you say inverse sine, and then inverse cosine, inverse tangent. All right? There's no actual, raising to the -1 power here. That's just how it's written down, okay, to indicate an inverse. You might remember to indicate a inverse function, you use the little -1 there. So it's the same kind of idea. That's a inverse of f of x, okay, or f inverse of x. All right, so now we use that inverse tangent function. So how I activated that on my calculator, I hit the second button, okay, and now we put in 16 divided by 8.6, and so this will give me the angle measure that has that tangent ratio. So 61.7 approximately has that tangent ratio, and that's our answer, okay? We figured out what the angle is approximately, 61.7 degrees. All right, let's do another one. So this one, we have the opposite leg, and then we also have the hypotenuse. Again, this is all relative to the angle, right? That's opposite the angle, and then, well, the hypotenuse is always the hypotenuse, no matter which angle we're dealing with. So which ratio involves opposite and hypotenuse? Well, that would be sine. Okay, so once again, I'm going to do it the long way, but you're welcome to use the formulas up above if you'd like. Sine of theta equals 10.4 over 13. Remember, this is opposite over hypotenuse. I didn't write it out first like I did here, but yeah, opposite over hypotenuse. And now, in order to undo this, we use inverse sine. Take the inverse sine of both sides. So we're left with theta, and yeah, you'll notice now this looks like the formula up above. So you're welcome to skip here, of course, right here, okay? Just my sides are reversed, but it doesn't matter. Okay, so now let me put that into my calculator, and it'll figure out which angle has a sine ratio of 10.4 over 13. So inverse sine 10.4 over 13, and we get 53.1 approximately. So that's our angle measure. All right, you guys go ahead and do number 7 and 8. All right, so on this one I got 74.2. I didn't show quite as much work, but I mean basically at this step from here to here I took the inverse cosine of both sides. Or you could think about it in terms of the formula up above. Number 8, this was tangent, right? We had opposite and adjacent sides, okay? So 4 over 3, took the inverse tangent of both sides, and I end up with this, which coincidentally is the same answer as number 6.